So this could take a long time, but I'm going to just it's just showing it picture by picture. I wasn't sure how the best way to do here's how you put together a whole thing in 45 minutes, so it's kind of an overview more than anything else. Here are the capacitors. They're up there too, so you can go ahead and try and snap them in if you want to into the power board, just to kind of see how it feels. Those, remember, those are the things that store the energy that from the batteries, so that every time the MOSFETs turn on, they need a ton of power really fast, and the capacitors are nice and close, and they're like, here, take it from us. So that works out good. Let's see here. Oh, there's one snapping a capacitor in. Hey, look, all the capacitors are in now. And then there's a big old base plate that I think is up there someplace, and you just kind of bolt that to the power section. That kind of carries the heat away, and it all turns into a nice little package. Ooh, there's the gate resistors. See those resistors there? That's like the bridge between the control section and the power section. It might be hard to see up there a little bit. Basically, the control section sends a signal really fast, an on-off signal, and then these gate resistors carry that signal, and then the power section turns on and off. It's kind of like having some little guy telling kind of like on that of Mice and Men, sort of, it's like the one guy telling the big guy what to do or something. So the little control board is telling the power section how much power there needs to be, and the gate resistors carry the signal. So let's see here. Okay, now, whoops.
On that, I was just curious, you were saying you ramp up on the power instead of, so your square wave wouldn't be exactly square? It'd be ramped on one side of the square wave?
Actually, it's still a square wave. It's just the, remember that picture of the MOSFETs that had the little duty cycle versus the bigger one?
Right.
It's just, it transitions from a small duty cycle to a big duty cycle in a gradual way. So you can't automatically go from tiny square wave to big fat one.
So the one that doesn't ramp?
Yeah, it's still a square wave.
Okay.
Yeah.
It's just the way.
Right, yeah. And, okay, let's see. So, next little part here. Whoops. What time is it? Of course, the little time thing is not showing. Oh, well.
11:26.
Oh, okay, that's not too bad. So, let's see. Next page. So, you have to connect the controller and the power section. He's the power section. And she's like, oh, I'm in the control section. So, and then once again, it's in the help file, 57 through 66. I guess I should have just stayed on the help file. But then you wouldn't have seen that wonderful picture. Okay, so you need the control board and the power board connected together, and it just walks you through. It's no big deal, there's a little, you need a 1/4-inch wrench, and kind of connect the two. There's little gate resistors connecting the power section and the control section. Come on, computer. I'm thinking, but it's not working. There it goes. And then once the two are connected together, it's done! Yay! And then you drive away. You need to stick some sort of enclosure on it. We have a kit that has enclosures. They're not real fancy, but they work. Or you can make your own. So let's see. Lots of people have done a lot of their own stuff, and it's pretty neat. I have some pictures of what people have come up with. Let's see here. So, some completed controllers. I'll just show, I don't want to show all of them because there's not a lot of time, but it's fun. Every now and then I see a YouTube video like on EcoModder or something that they post it, where it's this family, it's like they're showing their first test drive of their car and they used the controller or something, or like somebody over in some foreign land, someplace. Let's see, here's Ben. There he is, looking all innocent in the purple shirt. Let's give that close right here. This is, I mailed it to him like, okay, he's going to be all nice and gentle with it, right? So then he says, hey, look at this new video I made. Come on. So he's all sending these emails, or like these little videos, like, oh, that's great, man. Yeah. Okay, so, and there's people from all over the world. This is kind of a neat one. The EV BMW here. This is like, I think this is the first EV in Ireland. And he used the control board and then did a little bit of a different thing for the power section. And he's changed it to lithium. Top speed is 75. It's got a 100-mile range on it, and it's working really good. So it's most of the controllers that people put together are actually not from the United States. It's places like Scotland where gas is like $10 a gallon and stuff like that. So there's kind of a reason for that. This was a fun one also. Where is that? Let's see. Oh, that was a good one. Yeah, this one. I have no idea what the heck he's talking about.
Also, Fan faktisk siden sidst. Så vi se min genovervejning også. Jeg har også overvejning også. Det er også fordi, det er en dejlig dansk forår udenfor. Langt og længe sidste gang, så jeg mærke til det, så er det sne udenfor.
Okay, outside something.
Og også nu så lang tid, det er desværre.
Yay!
De optagelser, vi lavede, hvis jeg sad og byggede den her kontrol, tværs af computeren, virus, og
So lots of people all around the world have been using these. There's probably a total of maybe 300 cars, 200 to 300 cars that are using at least the control board over there. And then maybe 50 or 75 of just the full completed controllers that are, and it's this whole project that kind of grew, let's just stay here. Actually, this whole project, it just kind of really, I just was messing around not knowing what I was doing, and then people that actually knew what they were talking about started feeling sorry for me and offering all these helpful suggestions. And then it actually became really professional. Like the software is really fancy now, and some of the people, what they come up with for their actual bodies of their controllers, like look at some of these. This is the guy from Ireland, he did his thing, and then this guy is from New York, I think, and I don't know where these other ones are from, but people do all sorts of crazy stuff with them. And a lot of them are, you know, they've been going, and I don't hear very often about failures, so that's nice. Okay, so come on up and try soldering if you want to, and we can, oh, huh? Oh yeah, yes, and you know how you can have a controller, but then you just have this, but you don't know what to do with like the whole car. So fortunately, see our friend there, oh, I think he's got a sample. Do you have a sample of it? Yeah, he's got like a build a whole car DVD. Just the, huh? For cheap. Yeah, he's got a car that his was, what was it, $1,300?
Yeah, about $1,300 for the entire project.
Yeah, and what was your top speed at one point before?
I got it up to 73 miles an hour in a 55 zone with the open source controller.
Uh-oh.
I knew where the cops parked. That's why I had to slow down.
Okay. Let's see. Oh, and so then there's also our website here that I kind of glossed over a lot of stuff because of the time, but there's all sorts. You can see some videos of like, oh, then you put this together with that, or oh, here's the, you know, lots of different help videos there, and also just general help files that kind of walk you through the whole process. Oh yeah, business cards in there. Oh, good. Oh, in the slideshow. Okay, so are there any questions about anything? Uh-huh.
Can you purchase the DVD?
Yes. Yeah, they're available both at the bookstore right here. They're available through my blog, 300mpg.org, and I have a couple copies right here too.
He came ready.
Actually, I got a question.
Yeah?
Could I just say a few words about the
Oh,
project?
absolutely.
I just wanted to weigh in on this because Paul is a really super modest guy, and I only actually just met him in person on Friday. We both built our own electric cars. having no background in doing this sort of thing at all. This was a couple summers ago now. And we were kind of competing almost. And Paul could not change oil. And I'm thinking, man, if this guy can build an electric car, I can. So I was just always trying to beat him. And then after we built our electric cars, he manages to get his way through a conversion. And then he says, hey, why don't we build our own electronic controllers from scratch? And I'm like, holy cow, how is he going to do that? I was just blown away with these electronic skills that he has. Because I know nothing, absolutely nothing about electronics. I took a non-credit electronics class this last semester, which was interesting and still all over my head. But this has really been a fantastic collaborative project. People did not just feel sorry for him and weigh in. People wanted to see this project succeed. And this is completely open source. Everything that we've learned, everything that professional electronics people have weighed in, we put this all together and we put this all on site. This is anti-patented. All this information is out there. It's free. It's for anybody to use. Now, if you don't want to go through and order every little piece yourself, you can order a kit from Paul and it makes it a little bit simpler. But I can burn rubber in my car. It's very, very cool. The people all over the world building these things, it's pretty darn amazing, and it's an incredible sense of community. What's available through the blogs and the help has just been fantastic. So what I really think is great about this project, the sense of community, the sense of sharing and learning. So now we can go out there and we can do things, build our own electric cars and do it affordably because of people like Paul. So I want to thank him and everybody else that weighed in on the project. Like I said, I don't know anything about electronics, but I can design T-shirts. And I also test piloted his original controller, which was the scientific term, test until failure. It was my job to break it, and then we'd figure out what went wrong so that then future versions would be essentially bulletproof. And some of these are pretty amazing pieces of equipment. So I just wanted to let you all know how cool this thing really is and how modest Paul is. But this has really just been a fantastic
Are there any other questions? Oh, yeah?
I do have a question, actually, it's for Ben real quick.
Oh, yeah, here you go.
Yes.
Hey, Ben, when you built your electric car, and actually maybe you can weigh in on this too, Paul, about yours, but can you break down like what the costs were for like each bit? Because you said you built yours for like $1,200, you said, right?
Yeah, I bought a Geo Metro for $500. I sold parts off of it for $500. I put a $50 forklift motor in there. I started off with a used controller for about $300, a used charger for $200 or $300. I paid a machinist a couple $100 to do a little metal work because I didn't have a bandsaw or anything like that, and used batteries. And it came to about $1,200. Now, I think what'd you say? You bought your VW buck for like $200.
Yeah, mine was $200, and then I sold the engine in it for $160, so it was a $40 car.
Yeah, and then you got all those battery chargers at Harbor Freight for $20 each, so you just put one battery charger on each battery. I've still been running on the used batteries, but I won a contest a while back sponsored from Sears when I built my hybrid. And so what I'm planning on doing is buying some diehard batteries and putting it in there, getting some more speeding tickets.
That'll increase your range too, right?
Absolutely, yes. Yeah, more batteries. On these motors, the more voltage they have, the faster they spin, and the more batteries you have, the further you can go. So
For the amperage going in parallel, right?
all batteries are in series, but by them being in series at a higher voltage, a lower amperage is the same amount of power. But if you want higher amperage, you've got it. So if you're running a high voltage system like 144 volts, that's another thing. This project has grown. It started off as a 144 volt, 500 amp controller. There's now a 1,000 amp version. Now keep in mind, 100 amps is enough to do arc welding with. 1,000 amps is a lot of power. And then there's also an EC version going on for use with EC motors. There's a couple of cars electric cars out front. There's a Tesla Roadster, and there's a custom-built drag racing car. And the controllers that are being built through projects, like that 1,000 amp controller, that's starting to approach the drag racing controller that's in that drag racing Volkswagen out there. So there's features on these things. I mean, we're open source beating, not beating yet, but coming close. to some of the top of the line products that are out there. And this guys in the garages working together over the internet to make it happen.
So how would you increase your range then if you want to increase your mileage that you can go on a charge?
More batteries or advanced batteries such as lithium ion. It's just those happen to be kind of expensive. The Tesla Roadster has lithium ion batteries in it. It's a fantastic car. It costs as much as my house. And frankly, I don't need that many batteries to get to the grocery store and the bank and work and things that I need a car for. Plus, my car has more cargo room than a Tesla Roadster, so I got lots of room for groceries and a baby seat there.
What sort of range are you guys getting out of this sort of thing?
My car's range is not much. I just got 6 12-volt batteries. It's maybe 15 miles or something. But I have a top speed of only like 45 or 50 miles an hour, which is just fine all around town. And so I just plug it in at night and get my free tank of gas by the morning.
Another thing is that electric cars are modular. If you've got a controller that handles a higher battery voltage than you have batteries, all you need to do is add more batteries. Imagine having a car where you could double your top speed by putting more gasoline in it. That's what you can do with an electric car. More batteries, more fast.
So how many batteries are you running?
My car is always changing. I just can't leave it well enough alone. Most of the time I've been running with just 6 batteries in it. I've run it with up to 144 volts, 12-volt batteries. Top speed should be about 75 miles an hour on that car. But I don't need to go 75 miles an hour to get to the grocery store. So, how many do I really want to do? I'm probably going to go with a 9 battery 8-volt system. Nice and quick. Speed limit outside my house is 45 miles an hour. I really don't have a need to go faster than that. But I could just add more batteries. That's it.
Yeah, and now if you are you using like golf cart batteries?
I'm using sealed lead acid batteries. All my batteries were used. I bought them for $12 each. You know how if you buy a new battery at the store, you have to bring your old one in. I got some of the old ones that would have been brought in. So my car only has 6 batteries. Goes maybe 20 miles maximum, but I live 2 miles from the city, so 4 miles round trip. It's kind of overkill, but when I put some new diehard batteries in there with a higher voltage system, I should probably be able to go about 40 miles range, 75 miles an hour, that kind of a setup. And like Paul was saying before, we've got examples of cars where they've got lithium batteries in it. And yeah, they're more expensive, but it's running the exact same controller, it's the exact same hardware running everything on it. And the characteristics are really amazing. Like, I've gone for a ride in the Tesla Roadster. It felt exactly like accelerating in my car. Exactly the same for about the first 20th of a second. But really, it was impressive how the power electronics work, how it makes the car feel. When you drive an electric car, you smile. There's a term for it, it's called an EV grin. When you drive an electric car, you're not humble, but just smile. It's such a neat feeling.
Okay, any other questions?
2 minutes.
5 minutes? Oh my gosh. Oh yeah, go ahead.
Your top voltage controller that is
For that controller, yeah, but you just switch out the MOSFETs to 250 or 300 volt MOSFETs, and then you can increase the voltage. So it's just one line of those. You just switch with different parts, and it's
Has anyone ever calculated the efficiency of it at all?
Yeah, it's greater than 99% efficient. It's like 99.3 or 4 or something like that. There's not much heat loss because these MOSFETs were invented like a year ago, so they're not like Curtis, which is using MOSFETs for like 10 or 15 years ago. It's really fancy parts. Is what they were doing?
What's the limitations on the motor? Just the amp is all there is. So that was pretty
No,
that one
no.
limited to 5.
My motor is a 24 volt motor, and it's at 72 volts. I don't think that
I've got
rating means anything as far as I can tell.
electric forklift.
Oh,
I got
right.
the controller.
Yeah.
Bring them along.
But yeah, that's right. But you can just actually the controller also has hardware override protection where it doesn't really attack motor. It just protects from going too fast, so you don't have to worry about it.
Probably knows everything that's in there. That's a gorgeous lawnmower.
Any other questions?
Did a good job.
That's a cool
I saw the sign that said 5 minutes, but that was like 1 minute ago. Oh
I
yeah?
got one on both sides of that in the back.
Right.
In and out of the back. They both fire at the same The one stick.
Definitely not the starter batteries, because like starting batteries really thin lead plates inside. You can charge and discharge those about 20 times, and then you go throw them in the well, not in the garbage. Then you go recycle them. But the deep cycle batteries, the heavier the better, and because the thicker the plates, the longer they'll last and everything. But so usually golf cart batteries are a good choice because they're actually designed to really put out lots of power. Whereas marine batteries are made for a little puny trolling motor or something like that. So golf cart batteries are a good choice. But you could do a 200 or 300 mile range in a car if you just get a bunch of Thunder Sky batteries, like those iron phosphate.
Right in the driveway.
But you'd have to spend $10,000 or something like that. Not tons, you know, you could have a basically perfect replacement for your gas car for $12,000 or $13,000, I suppose. And you know, that's reasonable. I think.
That motor.
Oh yeah. Oh, okay.
I don't mind spending a-
And actually, if you break down all the parts, it's probably $350 maybe, somewhere around there. So, because I built this like a computer controlled mill at home where it's, you know, it kind of does like the little steps motors. And so there's a few precision drilling things, like you can go up there and check it out, like there's a few pieces of metals that you're kind of like, wow, I wouldn't be able to do that with my hand drill. But you can also talk to a machine shop if you wanted to go that route, just see. Because I could email you if you wanted the G code too, if you wanted to take some more. I don't know. Any other questions?
Do you have it?
All right, I'll hang around.
You know, schematic plan?
Yeah, like a kit comes in a box with everything in it, and then there's a schematic that shows all of the control section and shows you all what each resistor is and value and all that kind of thing.
What I was talking about, like these holes, do you have a plan that shows these holes in there?
Yeah.
Basic, so if you're doing it with hand and
Oh, yes. Well, for the control board, I've never seen anybody that's tried to put the control board together from scratch. But I suppose you could. Gosh.
you said there was a few holes that you might have to.
Oh, I just mean like in the metals, like in the heavy duty. Whereas the control board is much easier to get it. You make it on a computer with like a program like Eagle, you can send it out. Things like that.
Yeah. That so-called help file that Paul was paging through before, that's about 100 pages long, and it is step by step how to build one of these. So if you've never done any sort of soldering or anything before, it's like paint by number. It's the easiest thing in the world. So it's nice that he's gone through all the work so that anybody can build their own freeway capable electric motor.
Get that motor.
Let's all give Paul a big hand.